Hello everyone, a very warm welcome to you all. Today in this video, we'll be looking at the various data types in Solidity. Alright, so having said that, it's important to note that Solidity is a statically typed language, which means that the type of each variable, whether state variable or local variable, needs to be specified, alright, at the time of compilation before they are being deployed on the blockchain. So which means that when you are writing your smart contract, in Solidity, you have to specifically state the type of each of your variables. Alright, so having said that, data types in Solidity can be classified into two. We have value types and we also have reference type, right? So explaining the various value types, right? We have signed integers, unsigned integers, booleans, address, enums, and also bytes. Right, so moving to reference types, we have arrays, strings, mappings, and also structs. Okay, so when we say a variable is a value type, so this means that the data stores its own value. Take for instance for a boolean, it stores the value true or false. Take for instance for a signed integer, it stores the value -1, 0, and 1. For an unsigned integer, it stores value 0 and 1. So also when we talk about reference types, right, it means that this type of variable doesn't store its own value, but rather it stores a reference to where the value is being stored. So take for instance, an array is a reference type. So this means that it stores a reference to where its array elements are being stored. Okay, so in this video, we'll take a look at the various value types, especially signed integers, unsigned integers, booleans, addresses, enums, and also bytes. Alright, so without further ado, let's get started. So what are signed integers? Let's quickly break this down. We can declare a signed integer using the keyword int, which is pronounced int, right? So whenever you want to declare a signed integer, you need to use the word int, right? So the major use case for signed integer is to store either positive or negative values in your smart contract. So whenever you want to store values like -1, -100, or even positive values also, you can use integers. And it's important to note that int is an alias for int 256, right? So when it comes to signed integers, right, they have different ranges and different sizes, right? And these sizes are in steps of 8, right? And for int, right, it's an alias for int 256 with a range of -2 raised to the power 255 to 2 raised to the power 255 -1. So this means I can store value up to 32 bytes. So because it is a 256-bit type of data, right, it can store up to 32 bytes. Okay, so for a signed integer, right, the default value when no value has been assigned to it is 0. And also, like I mentioned previously, it has various variation in steps of 8. Take for instance, we have int 8, int 16, int 24. This means that these various values or these various variations have various sizes. So for int 8, it means that I can store value ranging from -2 raised to the power 7 to 2 raised to the power 7 -1. And also for int 256, it means that I can store value from -2 raised to the power 255 to 2 raised to the power 255 -1. I hope that makes sense. Alright, so moving forward, we also have unsigned integers. Alright, so what are unsigned integers? So you can declare an unsigned integer using the keyword uint, which means that anytime you want to specify the unsigned integer type in your smart contract, you use the keyword uint. Also, it's used to store either 0 or positive values in your smart contract, right? You can store values ranging from 0 to 200, 2 million, and all of those things. So usually whenever you're trying to store token balances or even the token amount, right, you use uint most of the time, right? And so uint is an alias for uint 256 with range of 0 to 2 raised to the power 256 -1. So it means that wherever you see uint, it also means it is what uint 256, right? And it has a size of 0 to 2 raised to the power 256 -1, meaning that you can store 256 bits of data. So when you divide this 256 by 8, it gives you 32 bytes, which of course is the maximum value for uint256. Alright, so when a uint256 doesn't have a value assigned to it yet, the default value is 0. Alright, also like I mentioned for signed integer, it has various variation in steps of 8. So we have uint8, uint16, uint24, uint32, meaning that it also has various sizes. Right, so take for instance, uint16 can store value ranging from 0 to 2 raised to power 16 minus 1. And so for uint32, you can also store value ranging from 0 to 2 raised to power 32 minus 1. Alright, let's move forward. So some of the things to also take note is you can make use of various operators when dealing with unsigned integers and signed integers. So you can make use of the comparison operators, less than or equal to, greater than or equal to, strict equality, bit operations, shifts, and also perform basic arithmetics like addition, subtraction, multiplication, modulo, and also exponentiation. Right? Usually, when you want to calculate the smallest and the biggest value that an unsigned integer or a signed integer can store, there is provision for that. So you just basically use the type keyword with the variable and the property min or max, right? So you get the minimum value that can be stored in that variable, and for max, you get the maximum value that can be stored in that variable. All right. Moving forward, we have Boolean, right? So Boolean is declared with the bool keyword. So whenever you want to specify that a variable is a Boolean, you use the bool keyword. And of course, it has two possible values, which is true or false. And when no values are being assigned to a Boolean, the default value is false, right? And it has a size of 1 byte. And it has operators like logical not. You can also do and also logical or, right? And they are supported. Okay, moving forward, we have address. This is really, really important because it is used to store EVM addresses. Take for instance your externally owned accounts, or even used to store a contract address in this case. And of course, these are like for EOA, this is like your identity on chain. And also, contract is used to store a piece of code, right? And so, for you to do this, you have to declare an address with the keyword address. So it can either have two values. One is an address, or one with the payable functionality, meaning that you can send Ether to the address. Of course, it has a 20 byte size and the default value is address 0. Alright. Moving forward, we also have enums, right? Enums are declared with the keyword enum, and it is used to declare a user defined data type, right? And in this case, where you want to specify that a variable or a data is in progress. Take for instance, purchase, you want to specify that a particular variable is either being purchased, bought, or in transit. So the major use case for an enum is to limit variables to a few predefined values, right? So you can also store constant value and also keep track of state. So like I mentioned for the purchase enum, you can check if it has actually been bought or it has been paid for and all of those things. Also for an enum, the default value is 0. All right, moving forward, we have bytes, right? Bytes are declared with the keyword bytes, and also it ranges from bytes 1 to 32, meaning you can have byte 1, byte 2, byte 3, and all of those to byte 32. And the default value for a byte 32 is 0x00. All right, so let's quickly take a look at some of those things that we have talked about. Let's practicalize it. And so to do that, we want to quickly create a new file called value types.sol. Oh yeah, this is going to be value type.sol. Okay, so very quickly let's set the compiler version and also the license type, right? So the compiler version is 0.8.0 and the license type is MIT. You want to initialize your contract by using the contract keyword and calling these value types, right? And pretty much it. So the first thing you want to do is to specify the int keyword, right? So we talked about signed integers, right? So to declare a signed integer, you use the keyword int, and let's specify the visibility to be public. so that we can view it right when it's being called after it's been deployed. So let's call this my int equals to minus 127. Alright, so this means that this is also int 256 because we mentioned earlier that int is an alias for int 256. Alright, so this means that I can store value from minus 2 raised to power 255 to 2 raised to power 255 minus 1. Alright, so this is the minimum and the maximum value that it can store, right? So basically in the case where we also want to have like a fixed size or fixed variation like unit 8, so we have to be able to understand what a unit 8 can store. So basically a unit 8 can store value ranging from minus 2 raised to power 7 to 2 raised to power um 7 minus 1. Alright, so this means that I can store values from minus 128 to 127. Okay, so as you can see, if we change this value to minus 128, it stores 128. We change this value to minus 129, then we get an error. Literal is too large to fit in int 8. Right, so this is the concept of sizes and variations. So for us to like upgrade this, we can either change this to unit 16. I'll be sorry, int 16. In this case, it's int 16 can store values from minus 2 raised to power 15 to 2 raised to power 15 minus 1. Alright, so the list goes on and on, even for other variations. So the next thing we want to talk about also is unsigned integer. Well, declare this as public, we'll call it my uint, and we set this equals to 1000. Alright, so just as we mentioned in int also, when we say a default uint, the default or the alias is also uint 256. So this means that I can store value ranging from 0 to 2 raised to power 56 minus 1, basically. Alright, so let's take a look at a fixed variation. Let's change it to unit 8, and it's showing an error. As you may know, that this is error is coming up because of the size limitation. Right, so let's check the amount of value a unit 8 can actually store. So unit 8 can store value ranging from 0 to 2 raised to power 8 minus 1, meaning that from 0 to 255, right? So in this case, we can't store 1000 because 1000 is too large for a unit 8 value type, right? And when we change this to 255, the error goes away, right? So this is the concept of variation and also the different steps. We can also do the same for unit 16, unit 18, and all like that. Alright, so the next variable we talked about was Boolean. We can call this, or we can set the visibility and call this is adult and just basically leave it. And as you may know, the default value for a Boolean is false, where we also want to set an address public. Let's call this owner and set it to msg.sender. So this is a global variable. It keeps track of the address that initializes a transaction, right? In this case, the owner will be set to the address that deployed this contract. Alright, so the next one is bytes. Now let's take a look at byte one. Let's set this to SHA1 because it is storing 1 byte, 0x00f, right? So this is a list of some of the value types that you commonly come across, uint, address, bool, and all of those things. So let's deploy this and see how it works. And let's deploy this contract. And here we have value type. So let's check is adult. The value should be false by default. My int, the value should be 120 minus 129. For my uint, value should be 255. Owner, the value should be the address that deployed the contract, which of course in this case is this account, right? And we also have SHA1, which is 0x0f. Alright, so pretty much it. Thank you for watching. In this video, we explained the various value type, and we also took a practical step to explaining some of these value types. right? And in the next video, we'll be taking a look at reference type. Thank you for watching and see you in the next video.